Welcome to the Refrigeration Mentor podcast. Super excited that you're all here listening again. I always, take the time to read the reviews. If you like any of the podcasts you hear, please like, share, and comment. This is how more people find out about it because we're really trying to uplift industry, bring the top guests from around the world. And this week, I have some good friends from HB Products. I've been meeting them more and more at the different shows. I learned about their product probably about 7 or 8 years ago. I might have knew about them before that, but really when I started learning about CO2, and actually the first manufacturer that I seen them on was Hill Phoenix, I believe, some of their CO2 equipment. It might have been Advanced, or I can't remember. It's been a long time, but I've been seeing more and more. And it's like anything I say, when you see something and you recognize it, you start to see it more and more and more. It's like a car. If you bought a car and that exact car, you've never seen it on the road before, but you buy it and all of a sudden you see it everywhere on the highway. So I'm excited about this conversation because I talk about these products, HB products, in a lot of my CO2 trainings because more and more people are seeing and asking questions about it. It's the first time I've seen it or I've seen it before. And really, how do I troubleshoot it or how do I use it? And I'm excited about this. Rooba, Henrik, how you guys doing?
Very good. Thank you, Trevor. Thank you very much for inviting us to this podcast.
Oh, well, super excited to have you. I know we have tons of conversation. We've been meeting at events all around the world, and it's always nice to get in a good chat. Rooba, why don't you do a quick introduction of yourself and let everyone know a bit about your role?
Yeah. So my name is Rooba, and I'm International Sales Manager at HB Products. So I'm taking care of the sales for our company. I don't know if I should do a short introduction of HB Products.
Sure, yeah, that'll be great, so people can learn a little bit more.
Yeah, exactly. So just very short, we are a company that manufactures different type of switches and level controllers, and we are a company based in Denmark. So all our production is done in Denmark, and we are very proud of that because we aim to have high quality products. So I'm mainly working with on the sales side, on the commercial side, and that's also why we have Henrik with us, who is more technically knowledgeable and is our product manager. So I'll give him the words.
Henrik, introduce yourself, please.
Fine. My name is Henrik Kudsk. I'm product manager here at HP Products. I've been with the company for 5 years, and I'm helping people and developing products that suits the needs for different applications. Our products are mainly capacitive sensors, and we use this principle for switches, for level sensors, and we have also introduced special sensors like wafer quality sensors, which can detect the amount of liquid coming out of an evaporator, and the defrost sensor, which can detect the amount of frost on an evaporator. So we're taking the capacitive measurement principle to new parts of the industry, trying to help people optimize their systems and saving some energy and making the world a better place.
Yeah, I like that. Let's just dive into that really quick because some people might not know what a capacitance sensor is. What does that really mean to someone who's new to it? Like, because I'm seeing more and more of these on CO2 and oil separators, liquid receiver or flash tanks. But when you say it's a capacitance sensor, can you explain what that really means?
It means you have a sensor which consists of 2 electrical poles, which is basically a capacitor. And when you add some liquid between the two poles, the capacitance increase. And you can either use it for detecting that you have a liquid or to measure the amount of liquid which is between the two poles. So the physical sensor normally consists of a rod, and around it you typically have a pipe, and when the space between the pin and the rod, the rod and the pipe fills with liquid, the capacitance grow, and you measure it, and we have an electronic unit which converts it to an analog signal for a transmitter, or just an on-off switch for switching.
Oh, that's amazing. We'll dive into more of that, because this is something that I talk about in our CO2 programs all the time. Technicians are like, it's not working. I'm getting an alarm. It's flashing red or green, or, and we'll talk about a lot of that stuff. But Rooba, I want to dive in a little bit before we dive in deep into technical stuff. I've seen you at a ton of events around the world, and you're out talking to different manufacturers. You're networking and growing your knowledge. And that's something I love doing. This is what I talk about to my community and all the people. We got to get out to these events to meet different people in the industry. What are some of the things that you really enjoy about going to these events? Because I seen you last week at the AHR Expo, which was really cool. And you travel all around the world to go to these different events. And like the people that I talk to in each country, when an event or an expo comes up, you got to try to make it there and plan to go. What are some of the things you like about these different events, like Chilventa, AHR Expo, China Refrigeration, all these different ones?
Yeah, it's definitely that you get an opportunity, especially, all this online stuff is very, very good. But I think sometimes it's very important that you get out there and meet the people face to face. And also when you talk technical stuff, it's good to have the sensors in your hand and they can see and touch. And it's way easier to understand, and you can cover a lot of the stuff in 30 minutes than using 3 hours online. And of course, it more and more the partners and the associate we work with, we become more like friends, and it's very good to touch base again and reconnect. Of course, I also love seeing you, especially when I'm around in the US. So I really enjoy this, that you can get out there and make new connection, and both mixing of business and pleasure, so to say. I love that.
Yeah, I know. I think that's the big thing, is building that relationships. You're right. The online stuff, the virtual stuff that we're doing even right now is great, but it's getting out there, meeting the people in person, building that relationship more. One of the things that you've been working for a manufacturer for many years, and you've seen people come into your organization. What are some things that you enjoy working about with a manufacturer like HB Products? So
I would say with our company, one of the unique things is also we are a family-owned company. So we have these family values, and that's also how globally we work with the different distributors and OEMs, and for us that's like our extended family, and that's also why I love traveling. And so sometimes it feels like visiting families. So that's one of the values, and that's also, like Henrik said, we have in-house. So even when people have some issues or anything, then we're always there to help. And that's how we do business. So that's also, then it's also important to be out there and meet them and, listen to their challenges and come up with new products to solve them.
Yeah. I have a lot of technicians who come into our training programs like, well, Trevor, I'm trying to transition off the tools into another role, either a service manager or a sales role or project manager role. And I see you worked at an OEM for a long time, or a manufacturer for a long time. What advice could you give a technician or anyone in refrigeration doing that transition? Because I did it myself, but I'd love to hear from you, because I'm sure there are technicians or refrigeration professionals who you've seen come inside your organization. What are a couple of tips you could give them for that transition, or would you have any tips?
I think as a technician, most important thing is probably you have to be open-minded and really work on your communication skills.
Yeah,
because that's what's required. And I would say as a technician, it's actually an easy transition, because you have already all this technical knowledge. You just have to be able to simplify them a little bit and be able to communicate, because often that's what I see with technician, is that you're very detail oriented, and because you have this enormous amount of knowledge, you want to spread it all out, and you have to learn to, keep it simple and communicate. Because in the beginning, it's more about, as I mentioned earlier, building relations and just introducing the product and the know-how.
Yeah, I like that. And I think that's the big thing too, is that communication, that's bang on. And a lot of technicians too that are in the program, they talk about how they're building that relationship with that end user, or that retailer. And it's a similar thing when you work for a manufacturer that sell to other manufacturers, is building that relationship with them. We do have the technical knowledge, but the big thing is that communication. So Henrik, what about a little bit about your background? Because you're in a technical role now, so you're dealing with all of it. So you're dealing with, I'm sure, because I've been there. You get contractors calling you, you got manufacturers calling you, you got retailers calling you, and it's always, not always, but a lot of times it's an issue. The things are on fire and it's falling down. But let's talk a little bit about your background. How did you even get into refrigeration?
Actually, I've been product manager for steel plates. I've been product manager for wind turbines and for reciprocating compressors in the business. So my background is actually a mix between a master in mechanical engineering and a marketing background. So I have both, and I love to try to simplify stuff and try to explain the complicated stuff in a simple matter, a simple way as possible. Trying to make people understand, not making it complicated. There's plenty of people out there who try to make stuff complicated and look smart and so on. I try to do the opposite, trying to explain how it works, cut the crap, and try to understand what people really need and help them with their needs. and that's also pretty close to what we have in our company here. We have a lot of electronic units. We have a lot of mechanical parts, and we put them together for different applications. And some of the stuff that we do, you can't do with standard products, with simple sensors which are multi-purpose. Like sensors we use for detecting oil in liquid ammonia. So we have switches which you can put in a vessel, and you can see whether they are in gas, in oil, or in liquid ammonia. So you can use the same sensor for detecting this. And we even have an advanced version where you can see for cascade systems whether the sensor is in gas, it's in oil, it's in liquid ammonia, or if you have a leakage of CO2 into the ammonia, where you create a salt which is blocking the complete system. So we are doing funny stuff by combining electronic units, mechanical units with good ideas, and listening to people who have problems, trying to build products based on that.
Yeah. And I think a couple of things that I took away from there, and this is what I talk about once again with a lot of technicians in our community, is like, you want to listen to the customer, because maybe it's not, you don't have that solution for them at this time. And you'll be honest with them. You're like, hey, I can't fix this because we don't have the right parts, or these are not the right parts here. We're going to have to look at a different solution. And that's doing what's right for the customer. And I know that that's very important to you guys. And me and Rooba talked about it before. You want to make sure that you can solve the problem. And that's why you guys build new components if you need to, you know what I mean? Or you try to test them out and see if there's a business case to it, because it all makes sense. You need to, if you build a product, it needs to be viable, right? You can't just lose money on a product. But you said something earlier too that I liked, it. It's like, keep it simple. You take a lot of support calls. What is one or two things that you've received where it is complicated, but you kind of explain it to make it easy for either that manufacturer or that technician or contractor in the field? What are a few of the examples you've seen? Because I know it's a repeat call. Like you do enough of it, like it's the same call you're getting in from different people from around the world. You know what I mean? So, but you got to get that. What are one or two things that are complicated, but you make it simple?
I think what I love to describe is the wafer quality control, which is fairly complicated when you look at it, and it's new to most people. And it's question of measuring or detecting liquid in the suction line, and the sensor as such is not that complicated, but the complicated part is putting it in the right place where you expect to see the liquid, and all the pitfalls when you talk about installing the sensor in wrong places, because it might be much easier to install the sensor on the top of a roof if you have a cold store. And it's much easier to install it up there, and you can look at it, you can control it, you can connect to it, and so on. But it just doesn't work. So we have a lot of customers who see this sensor and, oh, yes, we can install it on the roof. And we just need to say, no, you can't, because it will not work, because your riser will be filled with liquid as soon as you reach a critical part load condition. So that's some of the critical things, and you can explain and you can tell and so on, and you need to repeat, because it takes some time before people realize that their risers get filled with liquid.
Okay, what was the name of that again?
It's the wafer quality sensor.
Wafer quality sensor?
Yes, exactly.
And is it an immersion sensor? Sorry, Henrik. Is it an immersion sensor? Is it clamped on the outside of the pipe? How does it? Because I've never seen it before, but I'd love to.
No, it's in the pipework, and it detects the amount of liquid in the suction line, and you can use it for both DX applications where you like to replace the superheat measurement calculation with a real measurement to make sure that you have not superheat, but you don't have any liquid coming out of the evaporator. That's one application, but also in pump circulated systems, you like to have the same amount of liquid leaving the evaporator in part load as in full load, because you design your system for full load and you use it in part load. And what people do is they run this in part load, and they get their risers filled with liquid. And that just means you will need way too much refrigerant in your system. Your charge will be very high, and you have a lot of energy waste just by pumping this liquid around. And it's not the pumps which are pumping the liquid, it's actually the compressors which are working overtime. So we have a challenge with explaining people that in that riser pipe, they don't have gas, they have liquid, and it's filled with liquid. And we have seen a lot of customers who have installed the sensor and says, oh, something must be wrong with it because it reads 100%. No, it's just filled with liquid because your capacity is low.
So just so I'm clear on it, so that riser is going up to the unit on the roof. Is there a compressor on the roof? Is that correct, or is
it's just a pipework going to the roof and then back to the compressor?
And is just the evaporator below, or is it we're talking about below. Right now? Is below. Okay, now I get you. So now we got the evaporator below, and then we have the suction riser going up. That sensor, instead of being up on the roof, it should be down closer to the evaporator. Is that correct?
Exactly.
No, that's
Yeah.
I can picture it in my head because over the years of doing refrigeration, it took me a long time, 20 years. But now when I talk about, I don't even know the sensor, I've never seen the sensor before, but I can visualize it where it should be in there. And I think that's just years of experience where I talk to a lot of newer technicians like, Trevor, there's just so much to know. There is.
Mhm.
But if you find people just like Henrik and you ask them questions, you find a mentor or a coach out there, you ask them lots of good questions, and try to absorb as much as possible because it takes 7 to 11 times to really grasp something. Like
Yeah.
this is not the first time Henrik explained this. You know what I mean?
No.
Tons and tons of times.
Yeah, I think I've heard it for at least 7 times now. I'm not sure I can explain it as good as Henrik can.
Yeah. No,
Yeah.
I love that. So Rooba, some of the things that you do at your organization is building that relationships, having those communication conversation. What are some of the things that you've been seeing now, the trends with the OEMs and the manufacturers you work with? Like for an example, here in North America, we just had the AIMS Act in the US. Canada hasn't, because I'm in Canada, we haven't really changed any regulations, but we see globally F-gas regulations, AIM Act in the US. And Canada, where our regulations are going to come up. But what are you seeing some trends at the OEM level right now? Because you sell to all of them all around the world in different parts of the world. What are some of the trends you've been seeing?
Of course, heat pumps is a big thing here in Europe, and it's been that for many years. But I see that now more and more of the bigger players are looking into not CO2 as it has been the last few years. It's also going in direction of propane and isobutane and other natural gases. And that's one of the things I see. And I think they will be introducing more compressors and more products towards this. I think that's one of the biggest thing. And of course, US is also our market, and we see that it's slowly starting to change direction towards natural refrigerants, which is a very good thing. So that's also why I have increased frequency visiting to US, because I see there's a great potential for our products, because we have been on the market for natural refrigerant for many years and have great knowledge about that, so we can maybe help the transition.
Yeah. One of the things too is that I noticed that a lot of the equipment, like the products that you guys offer, I've seen it on large commercial or industrial applications. So it's 95% of it. I've seen it in CO2. I know you guys do it in ammonia and industrial. But what about for smaller systems? What do you have product offerings for, like just small commercial stuff, or is it more on the supermarket and industrial side? What other offerings do you have?
Yeah, so actually mainly we focus on industrial and supermarket size commercials.
Yeah.
So
me too.
we don't we don't have many products for smaller units, and that's also, we talked about AHR earlier. That's why it will not be a relevant platform for us, because it's mainly targeted towards this small units.
Yeah. And so you said that you're seeing more and more of like R290 or propane refrigerant or hydrocarbons, as well as there's A2Ls that we're going to see here in North America for a bit. Your product, do you have to design it different for these hydrocarbons? And what is that process? Because I know this is a big toll on manufacturers. I talk with technicians in our programs about it. I've been talking with regulars. I used to work for a manufacturer, and I've talked about it for years and years. But what kind of development needs to go into that? Because I'm sure, Rooba, you've been a part of that, and we'll ask Henrik next. But do your products need to be designed a bit differently for hydrocarbons?
So our products mainly consist of an electronical head with the software built in and a mechanical part. And what has to be modified is the mechanical part, because the picofarad value will be different depending on which refrigerant that we are looking at, and I'm sure Henrik will explain more about it. So what we need to do is we need to be sure to calibrate it correctly in the software and to design the hardware so it can go into this specific refrigerant.
Can you explain that word? Do you say pico factor, or what was that word?
Picofarad. I think Henrik will explain that too.
Okay, because I might have heard that before, but if you can explain, what does that really mean?
Yeah, the picofarad is the measure for the capacitance in the capacitor. So it depends on the fluid you have in your capacitor, and different fluids has different dielectric constants, and that's a number for how it impacts the capacitance in a capacitor. So water has a very high dielectric constant. It's super easy to measure. Ammonia is pretty good. But as soon as you reach oil, CO2 is actually the worst or most difficult one to detect. And that means...
Was that oil or CO2 or a mix of both?
CO2 is the most difficult to detect.
Awesome.
And hydrocarbons, propane, butane, is pretty similar. Okay. So to detect these liquids, you need larger sensors because basically to get the same output, you need a sensor which is 10 times larger to detect CO2 compared to ammonia.
Okay, that's why I see the different lengths of them. Some you have look like 4 or 6 inches. Some are like almost 12 or 18 inches long.
Yeah, the long ones are normally transmitters or level sensors, whereas the short ones are positioned horizontally and only detecting whether you have liquid or not.
Okay,
but they need to be slightly larger and more sensitive, much more sensitive. So the challenge with hydrocarbons and CO2 is to get a good measurement signal, because they simply need to be more sensitive. And there are some principles for measurement, also guided radar, for instance, which has problems with CO2. But we can do it with a capacitive sensor as long as it's large enough.
So this is a thing that I've talked about with a lot of technicians in my CO2 program, because I've heard it from the manufacturer that use your components. You can't just take a sensor and just use it for oil or use it for CO2 or use it for ammonia. There's specific sensors that's needed. And then if you mix that oil or mix that with something else, it may change the capacitance. Do you want to talk about that, where you've seen issues in the field where maybe the wrong sensor was used or a mixture of oil? Because the big one's oil for me, because a lot of manufacturers, I see them, they're in their oil separators or in their reservoir doing that sensing. If you have if someone mixes the oil, which we don't want to mix oil, you know what I mean? POE 68 or POE 85 or whatever. We don't want them to mix the oil, but will that change the capacitance or the way it senses if that happens?
It definitely will. But as long as you only have gas and oil, then it's okay to detect the liquid even if it's mixed. But when you have temperature coming into the picture as well, then it gets difficult, because it's all about this dielectric constant, which changes with which liquid you have, but also with the temperature. So and if you mix stuff, pardon?
You got a compressor background, so we know we do not want to be running hot discharge. And what does that? What happens in oil? The viscosity changes, and it gets really thin, and then your oil separator is not separating anyway. So now this will affect that sensor itself, you're saying?
Yeah, exactly. So oil is one thing, but actually CO2 is much worse, because if you look at the density of CO2, it's changing by a factor 2 if you go from above the freezing point to way below. So it's really sensitive to, and the detection is sensitive to temperature. So there are some challenges in the market.
Yeah, that's interesting.
You have to know what you're doing.
Yeah. So that's interesting because a lot of times I'll see it on the flash tank, that receiver or that vessel measuring the liquid level, because we want to know, you don't want too much liquid in that vessel or that flash tank or receiver, and you don't want too little. Too much, you're overcharged and it could cause higher pressures, and then you can lose charge out of your pressure relief. Too low, well, we're not maintaining any of the systems, and we can't pull the heat out of the product or whatnot. And then usually there's a range that I've always I see it's like between, say, 30 Fahrenheit or -1 Celsius up to maybe 40 or 10 degrees Celsius, not 10, like 8 degrees Celsius. But you're saying if you start to get colder, that's going to start to affect the capacitance, and all of a sudden the sensor may think there's liquid there and maybe there's not. Is that what you mean, as it starts to get colder and colder?
Yeah, you need to pay attention to temperature, and so the settings or the calibration need to comply with the temperatures, and that's tricky. And another tricky thing with CO2 is actually that the density changed so much that for cold CO2 you will have oil at the top and CO2 at the bottom, but at elevated temperatures it will be opposite. So there are some tricky things when you look into the details.
That's interesting, because so now design is very, very important, because if you start getting oil logging in a vessel, for an example, and it's not coming back properly, if you have if we have a warmer vessel, we'll say oil will be at the bottom and the CO2 will be at the top. But when we get colder, CO2 will be at the bottom and oil at the top. And so this would be like, okay, now it's not sensing the right liquid. Is that correct?
Exactly.
Okay, this is I'm learning so much. This is awesome. Oh man, so that's very, very interesting. What are your thoughts then on secondary systems? So now cascade system or secondary CO2 system. This is where we're running CO2 a lot colder, going out to do low temp applications, for example. Do you have to design those sensors, capacitance sensors, differently for the lower temperature, or is there a certain range, or what are the things that people need to watch out for? That oil, the temperature of the oil and the liquid ratio. So you need that oil to make sure it get out of the vessel somehow with some sort of orifice, or make sure that you get the oil out of the vessel. But what are some things that manufacturers now will need to look for, or technicians, when they're doing a lower temp CO2 application? Do they have to get a specific sensor for that? Like the manufacturer will have to get a specific sensor, or do they just use the standard sensors and just have to pay attention for that? I don't know if I asked that question.
Most of our sensors are designed for low temperature applications.
Okay. Cool.
So the only problem we actually have is condensation. Because there will be a lot of condensation if you have very low temperatures and like to detect the CO2. Yes. So they will be dripping wet, and that can affect the electronic unit. So you need to take care of that. But for as long as you go cold, we are pretty comfortable with the standard products. It's only the oil which can be tricky. It can be very stiff and difficult to return if it's coming out of an evaporator at very low temperatures.
Yeah, because it's really thick. And that's a good point what you pointed out there, because I had a technician a few years ago in my one of my CO2 trainings, and they're like, Trevor, we have the HB sensor. It's on the flash tank or the receiver, and it's flashing. and it's flashing, and that means that that solid state it's a solid state relay in there. Is that correct? In the
some of them, yes.
Some of them. So this example had a solid state, but it was flashing because it didn't make the continuity wasn't correct. But what happened? They said that moisture got inside there, in between the little cone. There's a little cone that goes into the rod, and that's where it's sensing if you got over 50%. I think it's 50% or 60% continuity. It'll say, okay, we have liquid or not. What's your recommendation when that does happen? Because there's a lot of moisture there. I was told use some thermal paste but what's your recommendation if moisture gets in there? They take it off, they wipe it off, they put the HB products head back on, that electrical part back onto the mechanical part. What's your recommendation if that does happen in these really cold and humid applications?
We try to avoid it by supplying a product which is proof to liquid. We have an IP65 series of products, but previously we also sold the more standard IP54 versions. Okay. And if you have one of those and it's condensating, you take the electronic unit off and you dry it, and you put some grease, same stuff you use for taps and stuff.
Electrical terminals, dielectric grease.
Yeah, exactly. To make sure that water can't really get in. But of course, you need to make sure that the small cone doesn't have this grease on, because it needs to have electrical contact. And then you can solve the problem. But the real solution is to get a product which is suited for these condensating conditions. Yeah. So especially if you go to the east, warm, humid conditions and CO2 systems, you'll have a lot of condensation. And, so we have a double program for most of the sensors for cold and for not cold conditions. And if you look at oil switches, they're normally in hot condition, warm conditions in a machine room, but sensors, especially for CO2, they are dripping wet.
No, and I've seen that lots too, and it's all about the application, the location, depending on where it's at in the world. Like there's a lot of factors in it, and if you're a technician out there, you got to get into the manual. All this stuff is in your troubleshooting guides too, because I have them in our training programs. I'm like, here, read the manual. Let's walk through it step by step. If you're working on these products, so you really understand, because a lot of the time, it's taking that signal, and that signal is sending it back to a control board, and that control board is doing something with it. It could be turning something on, shutting something off. So you really need to understand the sequence of operation. You guys build the components. You don't build the strategy on how it's supposed to work, So this is where I talk with technicians. You got to work with that manufacturer who are using these components and make sure that it aligns to what it's supposed to be doing. Because what you got, like what the product, HB products, the ones that I've seen, is going to do something. There's going to be, it's an on or off or a sensitive sensor doing something, but that's going back to a controller to notify another piece of equipment to turn on or off, or notify of an alarm, say, hey, we haven't seen liquid here for 25 minutes. There's something should be on, or we got liquid here for over 30 minutes. This is not right. We should not have oil in the oil separator for this long. There is something going on. We need to investigate. And that's in the control side of the manufacturer who builds that piece of equipment. Rooba, I got another question. What are some of the things that you're super excited about? Because the industry's changing. Even since you've been in the industry, we've seen it evolving and changing. What are some of the things you're excited about for HB product, or even the refrigeration industry in general?
I would say that I'm very happy about this transition happening to natural refrigerants, because I think that by now we all understand the dangers of PFAS, And happily, we have a regulation here in Europe now, and I hope that that will spread out to the rest of the world as well.
Yeah, I know. We've been at a few events together where they talk a lot about PFAS and TFAs and it's in a lot of things, not only refrigerants.
No,
you know
exactly.
what I mean? This is what I tell technicians, in a lot of other things. But if we can do something to help the planet and help ourselves, help our water, help our air, we should be doing it. We shouldn't be waiting. And if we have to be the first ones to push for that, that's important because at the end of the day, if our stuff, we didn't have leaky systems, we would still, we'd still be using the original refrigerants, R12s and 502s, but it just doesn't happen in refrigeration system. Mistakes happen or failures happen, rub-throughs happen, and you're going to have leaks. But now we know there's a lot of potential issues and harm that's coming to the planet and people. So let's make sure that we reduce the leaks and go with refrigerants that don't have those in it.
Exactly.
Anything else that you're excited? So the transition to naturals. What are some of the products maybe, or the things that you're excited about for HB products? Because you've been there, and I know you guys are still consistently developing stuff, and you have stuff in testing right now. That to come out to the market. What are some of the things you're excited about?
So one of the things I'm very excited about is the product that Henrik mentioned earlier, this wafer quality sensor, which actually gives you information about what's happening inside your evaporator, because you can measure. I sometimes say you can get an X-ray view on what's happening, so you can control your system based on data instead of just guessing.
Yeah,
and I love that about it. And I would also say with this capacitive measurement principle, I would say that our founder, Michael, who is founder of the company and also the one who have invented most of our product, is probably the guy who knows most about how to use this principle to implement it to sensors. And that's the part I'm very proud of as well. And we have also used that to develop this defrost sensor that Henrik mentioned briefly, that where we can actually measure the ice buildup on the fins of the evaporator in a freezing warehouse.
Yeah.
And again, that takes the guesswork out, because normal people would just say, okay, every 6 hour, every 8 hour, every 12 hour, whatever. And then that's it. Here we can just measure it and give you a signal, and then it's on demand. And the reason I'm mentioning this is also about, global warming and all that. We can reduce the energy consumption by implementing these simple solutions. So you only use energy when it's needed, instead of just defrosting all the time, because then you put in heat to a place where you're trying to remove heat.
Yeah. No, I know. And we've done this like here in Canada, like we've done heat reclaim in supermarket for decades. When I was 20 years ago, when I was in the field, I was doing heat reclaim, heat recovery, tried to have better defrost strategies. But you're right, like 20 years ago, 30 years, we were just throwing a lot of the heat out just to the environment. Let's just throw it out instead of reusing it. Now, 20 years later, we're trying to, how do we use as much of this energy as possible to benefit the end user, benefit the system, reduce energy, and reduce work, and that's like anything.
Exactly. Yeah,
I really, really like that. Henrik, how about you? And we're going to get into that defrost center. I'd like to learn a little bit more about that. But what are some of the things you're excited about, Henrik, for the refrigeration industry?
I think it's pretty much the same as Rooba said. The advanced control put on refrigeration systems can save a lot of energy.
I know.
The wafer quality sensor can in part load reduce the power consumption in a cold store by 50%.
Wow.
So on an ammonia system. And the price is the same for the system. So if people could just forget what they have done in the past and try to implement something which is smarter, we can save a lot of energy. And this refrigeration business is super conservative. I know they should, of course, build systems which work forever, but they should not use so much energy as they do.
Yeah,
the consumption is enormous.
Yeah, I know. This is what I talk about in some of our energy courses and our design. We have a CO2 design course, and we talk about like designing a system that you don't have to use as much energy. And because refrigeration takes a lot of energy, but it doesn't always have to. With these new strategies, does it cost more? And this is the thing. Sometimes it costs more upfront costs, but you get a huge savings over 25 year period. And it's hard to take. I had a conversation last week. You got big retailers where you got ops costs and capex costs and operational costs, and they don't always talk to each other. You know what I mean?
No.
So, oh well, it's going to cost more.
Two different budgets.
Yeah, two different budgets, right? So when I'm talking with technicians in our program, in our trainings, like you really want to understand the customer you're working at that time and try to figure out the best solution. And sometimes, they don't want to go with the best solution because it's too expensive, maybe. So you got to come up with multiple options. And that's maybe where this is a wave sensor, is a wave quality. What's it called again? Just a
vapor quality.
Vapor quality, cool. So that's where this may come into play. But also is the defrost. I want to learn just a little bit about the defrost strategy, because this is something I learned about 10 years ago. It's not new, people trying to do a defrost strategy. So instead of, like Rooba said, every 8 hours, every 6 hours, whatever it is, and it's just time. If it needs a defrost or not, is going into defrost. So I'd love to hear a little bit more how that works for this new product. Like, how does that defrost work? Or demand defrost? People have smart defrost or strategy defrost. There's a lot of different terminology I hear out there. But could you explain how that does work and what applications you would see it in, Henrik?
Yes, it's a capacitive sensor which is put on the evaporator. It's simply an stainless steel wire put between some of the fins, and it detects how much frost you have on the fins. And it provides an analog signal linear to the amount of frost on the fins. So if you have a cold store with 5 evaporators, you get a number on each evaporator, and you can defrost them as they get frozen. So you can, if typically the one close to the door will freeze up much earlier than the other one, and you will just defrost it when it has a reasonable layer of frost. Whereas the one in the background of your cold store maybe should have a defrost every 2 days. The one in the front could be defrosted every 3 hours in summertime and every 7 hours in wintertime. So it will depend on how much moisture you have reaching the evaporator, and not just average number put in by the one who installed the evaporator. And when looking at benefits and costs and so on, we normally aim for at least reducing the number of defrost cycles by 50% compared to a conventional timer-based system. And that makes a huge impact.
Yeah, we could do a whole episode on this. But so one of the things, so it's a wire sensor. It has to go on a specific spot. So it might go on one spot on one evaporator coil and a different spot on another one, just depending on how the frost builds. Is that correct? Or is it in the same location? What do you recommend for the OEMs or the technicians who are putting it on?
If it's an existing system, you will know where you have the frost buildup, but it's normally on a pump system. It's on the air inlet side. You put it between the fins, and you put like 4 or 5 meters of this wire, and that will do the trick.
Okay, I love it. 4 or 5 meters, so that's like 15 feet, something like that, 20 feet. Yeah. Okay, so the next question, I had a conversation with a technician down at the HR Expo where they're running into a defrost issue, where they have 5 cases on the line. but two of the cases just keep freezing up. And one of the things is, just like you talked about, these two cases get a lot of moisture inside or a lot of air infiltration, and they start to freeze up a lot faster than the other ones. But when they defrost, they all defrost at the same time. So when someone's designing these systems, just say if those 5 evaporators that you talked about are on the same circuit, do you recommend having solenoids on the suction lines or for those systems for those defrosts? Because and what I'm referring to is more of a hot gas defrost system versus electrical defrost system as well.
Yeah, you should only defrost when it's needed, and split the evaporators into sections, so you can run defrost only when needed.
Yeah, which costs a little bit more up front. Once again, you know what I mean? This is going to cost more up front. If you have 5 circuits and you're going to add 5 solenoids, or if you got to pipe each one of them individually off that, say, loop system, it's going to cost a little more up front, but the long-term benefit could be there. So this is why you want to work with the manufacturer, work with the experts like Henrik to find out more. Final thoughts for the industry. What is, Rooba, first from you, what are 1 or 2 tips you could give to, say, a technician or, say, one of your manufacturers that you work with about the refrigeration industry? So 1 or 2 tips, because you've been in it for a long time. You've seen a lot of things. Someone just starting out in industry, if they're starting out as a technician or starting out at the manufacturer, what is some advice you could give them?
That's a good question. I would say that especially in this transition is happening from HFOs to natural refrigerants. So I would probably start looking into how can I apply my skills. And I know for sure that if you are a technician in the refrigeration industry, then you should consider yourself very lucky, because there's fewer and fewer people there, and it doesn't matter which country I go to, I hear the same thing. We don't have enough technicians. We don't have any skilled workers. I know countries in Europe who started to import is maybe not the right word, but getting people from Indonesia and training them by themselves and teaching them the skills so they have some technicians.
Yeah.
So
I like that.
So if you are into the field, then just start educating yourself, and a good place to start with. I know a guy who is very good at teaching people.
Yeah.
Yeah.
Awesome.
So yeah, I think it's important, because, as I said, there's a big lack out there for industry technicians. So yeah, educate yourself.
Educate yourself. I love that. Henrik, same thing. Someone new starting in the industry, could be a technician, someone getting into OEM. What's 1 or 2 tips that you could give them if they're just getting into the industry, if they're working a little bit in it so far?
Yeah, I think people should think of something new. The old stuff is not necessarily the way to go. Try to see what's going on, follow the trends, and follow that route instead of just doing what your dad did and your grandpa did. That's not the best solution any longer.
Yeah, exactly. Like electronics. I talk about this, like I said, in a lot of our supermarket programs or CO2 programs. It's electronics, it's controls, VFD. You need a computer now. Not all the time, but this is, we're using our phone to troubleshoot systems today. You know what I mean? We're using computers. Yep. We're on a control system, and we're reading trend graphs, just like you guys were talking about there. The defrost, smarter demand defrost. Yep. You're going to watch it, and he's, oh, well, it's frosting up. Why did it frost up this much? Did something happen to that element? Is it wired correctly? And I think going forward, we need to understand more electronics. And this is, a lot of it can be intimidating. You know what I mean? You guys know. You see it all the time. You'll go to an industrial system or a CO2 system, and there's controls everywhere, and wires, and there's sensors everywhere. And a lot of the technicians are like, it's just so overwhelming. It can be. And I was there too 20 years ago. But if you step back and look at the bigger picture, how does this really work? Well, we're moving energy. We're moving heat from one place to the other. And when you really understand that, how it moves there, well, what does it need to do to move there? and then just work your way through that. This was a great conversation. I know we'll do it again. How can people find out more about HB products or find out more about you guys?
Yeah, so we have our homepage, hbproducts.dk, and then we are also very active on LinkedIn. And we have a lot of good content on YouTube, especially small troubleshooting videos and explainer videos about our products. So, yeah.
Awesome. Well, I want to thank you guys.
Yeah.
Go ahead, Henry.
Yeah, and we'll be happy to help. But of course, we don't want to repeat ourselves. So we have a lot of good stuff on our webpage.
Yeah, no, I've checked it out. I send people there all the time too. So the more you learn, the more you're going to grow. Even if you're not working on their products today, go check it out. You know what I mean? Because maybe you will see it out there, and then maybe it'll give you an idea of how you can implement a product just like that into a system to really help your customer at the end of the day. I want to thank you guys so much for taking the time to chat with me, and look forward to seeing you at more events, Rooba, more conversations with you, Henrik, on the technical side. And this is it. It's growing your knowledge, learning and growing, taking the time to invest. If you like this episode, please share it, like it, comment on it. This is how more people find out about it. We're trying to uplift the refrigeration industry to really help more people. And as always, let's get a conversation going, everyone. See you.